Okay, this is going to start the first of two videos for the section 1.8 inverse functions. You're basically going to see in this video why in the last section we did the whole FOG and GOF. You're going to see how that relates to inverse functions. Now I'm going to kind of go over two definitions of inverse functions. One is a very informal way, which might give us more meaning and more purpose. The formal definition is going to have to do with all the compositions that we did with FOG and GOF. Okay, informal definition of inverse functions. Let's just first go over the notation. We know if we have a function, we can say it's function of x. And if that function has an inverse, this is how we can write it. We can write it f raised to the negative 1 of x. That means that those two functions are inverses of each other. Now here's kind of the informal definition. That was just kind of the notation I gave you at first. The informal definition is that basically for these two inverse functions, the x and y values, you can see that, switch. So basically if I make an xy chart for f of x, then the x values in that, they're going to be the y values in it for the inverse of function of x. Let's take a look at an example of this informal definition. I'm going to tell you right away, these two right here, for the example, f of x is x plus 4 and g of x, x minus 4, they're going to be inverses of each other. I'm going to show you why using the informal definition. I'm just going to make up a quick xy chart for each of these. Okay, and I'm just going to put in 0, 1, and 2 for this. Okay, I know if I put in 0 here, right, 0 plus 4 is 4. Then I put 1 plus 4 is 5. 2 plus 4 is 6. Now for g of x, now as I said, they're going to be inverses of each other. When I do the xy chart, I'm going to switch the xy chart. So these y's I'm going to put here as the x's. So I'm going to put in 4, 5, and 6. And when I put this in here, right, I put in 4, 4 minus 4 is 0, 5 minus 4 is 1, 6 minus 4 is 2, and there it is. You can see right here, you know, this ordered pair is 4, 0, but for f of x it was 0, 4, and so on. 1, 5 became 5, 1, 2, 6 became 6, 2. So that's kind of one way to know, and that'll really help you to graph. If you have a function, you could easily graph the inverse function by just switching all the ordered pairs. What I'm going to do next is I'm going to get to the whole composition. I'm going to go back to FOG and GOF. I'm going to erase this right here. I mean, if you have room, try to fit it in. If not, no big deal. Just watch and just try to understand what I'm going to do next. All right, I'm going to erase the XY charts. And then I'm going to find FOG and GOF. And we're going to see something similar happen when we do both FOG and GOF. Okay, if I do FOG, right, I'm doing f of g of x. So really I'm finding the function of x minus 4. So this x minus 4 I put into this x. So then that's x minus 4, and then I bring this plus 4 down. Well, these 4's cancel, and it just equals x. Okay, let's do the opposite. Let's do GOF. So GOF is g of function of x, which is g of x plus 4. Now this x plus 4 I'm plugging into this x right here. So then it's x plus 4, and then I drop down this negative 4. And you can see the same thing happens. The 4 and negative 4 cancel out, and it equals x. All right. You're going to see that when you have two functions that are inverses of each other, whenever you do FOG and GOF, and if f and g are inverses of each other, they always equal x whenever you do FOG and GOF. Now that is the formal definition. So let's put this down for the formal definition. Okay, for formal definition, we'll say, let's put if f of g of x equals g of f of x, and they both equal x, then we can conclude that g of x is the inverse of x. And we'll use a notation, which is f to the negative 1 of x. All right? So kind of the x's and the y's switch, and also we can do FOG and GOF. All right, we're just going to do 2 examples, and we're going to do the whole FOG, GOF, and prove that it equals x, or see if it equals x. Okay, for this first one, it says verify that g of x is the inverse of f of x, and it gives us the 2 functions. Now here's the key word. It says verify. Now just think of it. If you ever say, hey, verify this or prove this, that means that it's true. You just have to prove it. So I have to prove that FOG and GOF both equal x, but I have to show all the steps. So I'm going to do f of g of x, which in this case is f of 5 over x plus 2. Now, since you're basically proving it, kind of go back to your geometry days. When you did proofs in geometry, remember how you had to show every little step? You have to do the same thing here. You can't just kind of throw it in and say, oh, it equals x. You got to show everything here. You have to show all the math. All right, so if I put this in, I'm going to take this whole quantity and plug it right into this x. So this is going to equal 5 over, and then the bottom I put in 5 over x plus 2, and then this minus 2, I bring that down. Now these 2's in the bottom, they cancel out. So this equals 5 divided by 5 over x. Now this is what I mean, how you have to be real detailed and you have to show all your steps. You are dividing by a fraction 5 over x, so you have to show that step. I'm going to take that top 5 and I'm going to multiply it by the reciprocal of this. So it's x over 5. So the 5's cancel and it equals x. Alright, so I'm halfway there. Let's do g of f of x. So when I do g of f of x, that is g of 5 over x minus 2. Okay, and I'm just going to erase all the stuff that I just did, so make sure you have that down. Alright, so I know this has to equal x here. Alright, let's put this in. So I'm going to take this 5 over x minus 2, and I'm going to plug it right into this right here. So let's put it right up here. This is going to be 5 over. Then you have the other fraction, 5 divided by x minus 2. And then this plus 2 you bring down. So it's just plus 2, kind of hanging on the side there. I'm going to do the same thing here, the keep, change, flip. I keep the top the same, which is 5. I multiply by the reciprocal of this, the bottom. So it's times x minus 2 over 5. Okay, these 5's cross cancel, and then I'm just going to bring down this plus 2. And then this negative 2 plus 2, they cancel out, so it equals x. So I showed all the steps there. So I put a little check mark. I prove that FOG and GOF equal x, so therefore they're inverses of each other. Okay, the last one says are g of x and f of x inverses of each other. So what you're doing there is you want to do the same thing, but now it's not saying verify, so you don't know if they are. So basically, if you do FOG and GOF, and if they both equal x, they're inverses. But if you get something other than x, then you can stop and just say right away, they're not equal to x. All right, here we go. Let's do FOG of x. So let's do f of g of x. So we're doing f of 1/3 x plus 2. Okay, let's plug that in. So this we're plugging into this x right here. So this is going to equal 3 times this whole quantity of 1/3 x plus 2. Then this minus 2 I bring down. Let's distribute this 3. 3 times 1/3 x is just x. And then 3 times this 2 is plus 6. I bring down the minus 2. And this doesn't work. 6 minus 2, we get 4. So this is x plus 4. I can stop right there. I don't have to do GOF or G of f of x because this doesn't equal x. So my answer is a big no. These are not inverses of each other. All right, so the big thing that you got out of this is that if they're inverses of each other, the x's and the y's switch in the xy chart, and then FOG and GOF both have to equal x. Tomorrow we'll probably start out class with, we're going to go over why. Why do they both have to equal x? And it has to do with the graphs of inverse functions.